All right, in this video, we're going to go over the chain rule, which is basically the rule that we use for composite functions, taking the derivative of them. So for the following composite functions, before we actually get into the chain rule, what I want you to do is identify your inner function, your outer function, and then the derivative of both. Number one, it'll be good practice, and at number two, it'll lead us to discover the chain rule. So first, let's look at this first one. So your inner function is 1 plus x squared, and your outer function is the root of x, or square root of x. The derivative of your inner function then would be 2x, and the derivative of your outer function, remember we can rewrite this as x to the 1/2 power, would be 1 over 2, and then x to the negative 1/2, or in more precise terms, 1 over 2, the square root of x. Okay, so these are what we have been able to do in the past for just individual functions, and now we're going to start combining them all. So if you want to pause and go ahead and do the rest of them, feel free, or you can follow along with me. Your inner function is 2x for this one. Your outer function is sine. Derivative of the inner function is 2. Derivative of the outer function is cosine. Inner function is x minus 1. Outer function is x cubed. The derivative of your inner function would just be 1. Derivative of your outer function would be 3x squared. Let's see this one. Inner function is 3x plus 2. Outer function is x to the 4th. The derivative of your inner function is 3. The derivative of your outer function is 4x cubed. All right, it looks like we got two more, so let's go ahead and do those ones. The derivative, or my inner function here is x squared, and my outer function is tangent. The derivative of x squared is 2x, and the derivative of tangent is secant squared. That's one of your flashcards you have to know. And then for our last one, this one's a little bit tricky because the way to rewrite this to identify that it has an inner and an outer function is cosecant squared. So then your inner function, is cosecant. Your outer function is x squared. The derivative of your inner function is negative cosecant cotangent. And again, that's another one you have to have memorized. And the derivative of your outer function is 2x. Awesome. So now what we're going to do is we're going to be taking these pieces and we're going to be discovering how you get the derivative of sine of 2x from this information or from what we found. And one of the ways that I normally do this in school is we have you utilize the website Wolfram Alpha. And so I'm going to show you how to use that. And it says we're going to go to that website and then we're going to enter what we want to calculate or know about. And you can literally in that website type find the derivative of blah, 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 and then hit enter on your keyboard or the equal sign on the screen. And so then we're going to fill out the table below by using this resource. And then we'll be able to come up with a pattern using your derivative rules. So let's look at the first one. So I'm going to go to Wolfram Alpha, and it's square root of 1 plus x squared. So I will type in here, I'll say find the derivative of square root of 1 plus x squared. All right, so they give me x over the square root of 1 plus x. So I'm going to go ahead and I'm going to put that in here. X over the square root of 1 plus x squared. Lovely. For this next one, we'll say find the derivative of sine of 2x, which gives me 2 cosine of 2x. 2 cosine of 2x. Find the derivative of the next one is 1 minus x cubed. So negative 3, 1 minus x squared. And then in the next one, we have 3x plus 2 to the 4th. Which is 12, and then parentheses 3x plus 2 cubed. Awesome. And then let's go ahead and look at the next one. For this one, we got tan of x squared. So we're finding the derivative of tan of x squared, which is 2x secant squared of x squared. 2x secant squared of x squared. And last but not least, cosecant squared of x. I think it'll let you type it in this way. Yep, negative 2 tangent cosecant squared. Cosecant squared. Awesome. All right, so then based off of these examples, we're trying to see if we can find a pattern. So write out your guess by filling in the right side of the following equation. So when you have a composite function, so f of g of x, how do you find the derivative of that composite function? Now these are all made up of pieces of the inner function, outer function, and its derivative. Specifically, the one I would like to look at is the sine of 2x, because I think its derivative gives a really good example of the answer, basically. So normally we have sine of 2x, and then its outer function was sine, inner function was 2x. And so if we look in here, I notice that I have cosine, which is the derivative of my outer function. My inner function in the derivative is the same as what I had out there. And then this 2, where does this 2 come from? Well, this 2 comes from the derivative of your inner function. So it looks like we had our, if I'm looking at everything that happens, I have the derivative of my outside function with my inside function remaining the same, and then I could have written, I guess, this 2 over here at the end, right? I don't necessarily need the 2 to be right there, times the derivative of my inner function. And so that's the rule. That's basically the pattern. And ideally, like I said, you guys would come to this conclusion on your own, but it's okay if I get you there a little bit too. So if you have the derivative of an outer function, inner function, composite functions, the derivative of that would be the derivative of the outside function. Keep our inside function the same, and then you multiply by the derivative of the inside function. Excellent. So there isn't, I don't have a particular like mnemonic for you to remember this one by, just basically that phrase that I just said, derivative of the outside, keep your inside the same, times the derivative of the inside. And then we can also, I'll show you how I kind of go through and use this formula on composite functions. So if you have derivative of tangent squared of x, for example, I usually identify my outer function and my inner function. So my outside function is, remember, another way to rewrite this would be tangent of x squared, and then my outer function would be x squared. My inner function would be tangent of x. And so then I find the derivative of my outer function, which is 2x, and the derivative of my inner function, which is secant squared of x. And then this is kind of how I navigate that. So I do derivative of my outer function, keep my inner function the same. So I'm actually plugging this back into my input, and then times the derivative of my secant. Let's see if I want to rewrite that in a different way. So you use your outer function, keep my inside the same, times the derivative of your inner function. So my answer would be 2 tangent of x secant squared of x for that one. All right, let's try it with this piece as well. So here's my outer function is square root of x. My inner function is 16 minus 4x squared. The derivative of my outer function is 1 over 2 square root of x. The derivative of my inner function is negative 8x. Derivative of my outer function, I skipped all the middle steps getting there, but this is one we use pretty often anyway, so you'll eventually probably memorize it. All right, now we do derivative of the outside. Keep my inside the same, times the derivative of my inside function. So I get 1 over 2 square root of 16 minus 4x squared times the derivative of your inner function, which is negative 8x. Technically, you can simplify that further as well. So negative 8x could go up here on top. So then I have negative 8x, and negative 8 over 2 simplifies a little bit. So we get negative x over, negative 4x just over the square root of 16 minus 4x squared. So that's 2 examples of using the chain rule. Don't worry, we're going to do more.